All right, so we're going to continue. By now you've tried the others and you're just going to be coming in here and trying to check to see if you had the right idea. Okay, so we're starting with number 22. All right, so this one has a hole at x equals, looks like 9. So that means you should have an x minus 9 in the denominator. Okay, you have a vertical asymptote at x equals 3. So you should have an x minus 3 factor in the denominator. Okay, it has a horizontal asymptote at y equals 2, which means you should have the degree on the top and the bottom being the same. Okay, so the same number of variables on the top and the bottom, but when you look at the ratio of the leading coefficients, you should have a 2. Okay, so degree 2 on top and bottom, all of these two are degree 2 on top and bottom. These are degree 2 because that would be an x times an x on top and bottom. All of them have that horizontal asymptote being 2, even this one. Okay, so they all have the degree correct on top and bottom. All of them work with the horizontal asymptote idea. All right, so let's check the vertical asymptote. It has to be x minus 3 as a factor in the denominator. So that guy's out, and that guy's out. Now, these are basically equivalent to one another. They're equal everywhere except for where x equals 9. So when you do your limits later, you'll wind up taking advantage of that. Okay, because the limit of the original function at every single point is equal to the limit of function in B is equal to the limit of the function in C everywhere. Okay, the fact it's undefined right there at 9 doesn't really matter. Okay, so but the correct answer for which equation goes with that graph would be B, because the x minus 9 top and bottom, that's a fixable problem. That's what causes the hole to happen. Okay, all right, let's look at 23. I think that's a hole right there at -4. So that means at x equal -4, you're going to have a hole. So that corresponds to an x plus 4 factor in the denominator. Here I have a vertical asymptote at x equals 4 corresponds to an x minus 4 in the denominator. So right there, I'm thinking it's one of those two. All right, now I'm noticing how this is appears to be crossing the x-axis right there at that -4. All right, so that means that that would go with this guy. Okay, the numerator should wind up turning out to be -4 when you set it equal to 0. Okay, all right. The other thing I might consider, but it just didn't help me, is that the horizontal asymptote was y equal 1, which just means the degree has to be the same on the top and the bottom. But that's true on both of these, isn't it? Okay. All right, you could also plot just some other point, like you might consider the y-intercept. Looks like it's around -1. So you might consider putting in a 0. And if you did, you'd get a 16 on top, -16 on the bottom, okay, on that one. But sometimes it doesn't help you. If we put a 0 in here, a -4 squared would still be 16, and I'd get a -16. So it didn't help me on the y-intercept, but it did help me see how it appears to cross at that -4, even though it's a hole. So I need to have the x plus 4 top and bottom. Okay, so the x plus 4 top and bottom, not the x minus 4. Okay, so that would be the answer to that one. All right, let's look at 24. I don't see any holes. All right, so vertical asymptote at x equal 3, so x minus 3 in the denominator. Okay. Horizontal asymptote can come into play. I see it at y equal 2, which means I should have the degree the same on the top and bottom, and then a 2 out in front here. So I should have the same number of x's and then a 2 out in front. Another thing I could do is this is a 6 and a 0, so it crosses the x-axis at 0 and 6. That means the numerator is going to have an x and an x minus 6 factor, so that when you set that equal to 0, you get the 0 and the 6. Okay? And then I need the degree to be the same on the top and bottom. But if I have an x and an x minus 6, then that's degree 2 on top, but only degree 1 on the bottom. Okay, so that's not going to give me a horizontal asymptote. So I'm going to need that x minus 3 to be squared to make it degree 2. Let me see if that fits everything then. Yep, sure does. So x minus 3, not x plus 3 in the denominator. I need an x and an x minus 6, which I've got on all the remaining ones. This guy's out because I would need a 2 to get that horizontal asymptote. And then this guy's out because I'd need the degree to be the same. So 24 is going to have to be D. All right. Let's look at 25. We have two vertical asymptotes. One of them's at x equals 0. That's the y-axis right here. Other one's over here at what appears to be 8. So those are going to correspond to a factor of x and x minus 8. And think of it like x minus 0 and x minus 8. That's going to be in the denominator, and x minus 0 is really just x. So I know this much. Okay. Well, right there, I've eliminated just about everything. Notice it's crossing the x-axis around 7, so that's why there's an x minus 7 on top, because that would have to equal 0. Doesn't appear to be crossing anywhere else, and it's got a horizontal asymptote of y equals 0, which means you need the degree on the bottom to be more. So I think it's this guy right here. All right, which is B. Okay. All right. All right, so we're almost through with the graphs. These really just kind of help to talk through a bunch of them. All right, I'll try to be a little quicker though. All right, so on 26, I don't see any asymptote. So the denominator can't have any places where the function is undefined. All right, so that means it has to be not, oops, I gotta snip it. Okay, so it can't be B or C because there would be places where those denominators are undefined. Okay, then the Y-intercept might be the next thing to do. Maybe plug in a 0 and see what you get. If you put a 0 in, if you do f of 0, you'll get a -2 over 1 on that one. If you plug in a 0 there, you get a -2 over 5, and that should have a y-intercept of -2. So it's A. Okay. All right, let's look at 27. 27 has a slant asymptote, so the degree on top is 1 more. Okay, which is true here, 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 and here. So that fits all of them. Okay, now vertical asymptote at x equals, gosh, I need to blow that up a little bit. X equals -2 would correspond to a factor of x plus 2, have to be in the denominator. So that eliminates these guys. All right, and then what these two would look like, a negative x squared plus 9 on top versus an x squared minus 9. There's where, again, I might look at this, consider what would happen if I divided this to find my equation. And if I divided that, see how that's going to go in there negative x times? So you'd have negative x squared minus 2x. When you change the signs, that would become 2x plus 9. And then you'd go again and you'd get x into 2x 2 times. So you'd wind up with your slant asymptote being y equals negative x plus 2. So see how it's a negative slope? That would have a slope. The slant asymptote right here should be falling. So that guy's out. It's this one. And then you also could just pick some points to double check on that. Right? So maybe the Y-intercept again. All right. If I plug in a 0, I'd get 9 halves on this one. If I plug in a 0 here, I'd get a negative 9 halves. Okay. So 4.5 versus negative 4.5. So you could do that also and see how it's down here at negative 4.5. So it has to be D. All right, let's see about 28. Okay, asymptotes at x equals negative 6 and x equals 5. Okay, so that means I need an x plus 6 and an x minus 5. And actually, that's what x squared plus x minus 30, when you factored that, you get those two things. So all of these have the correct vertical asymptote. All right, now let's see what else we can figure out. It has a horizontal asymptote at the x-axis, which means the degree on the bottom has to be more, has to be bigger, which is true here, 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 and here. So that part's also true. You know, it looks like it crosses the x-axis at 0. So that means the numerator would have to, let me look at that. Stretch that a little bit. I'm not really sure, but it looks like it's crossing somewhere in here. So that means the numerator would have to have a variable so that you could have that turn out to give you a value where that equals 0. So it can't be this guy. Okay. And then I don't think it's this guy because the numerator would equal 0 when x equals 1. And it looks like it's crossing more over to the left. It's shifted to the left a little more. So I don't think it's that guy. You have to have a variable, so it's not that one. So that makes it, in my mind, C. That's how I would analyze that. Okay. All right, let's look at 29. Okay, we've got vertical asymptotes at x equals negative 2 and x equals 3. So the denominator would have an x plus 2 and an x minus 3 factor. If I multiply that out, that would be x squared minus x minus 6, not the one with the plus in it. So those two are out. Okay. All right, let's see now. It's got to have a horizontal asymptote, appears to be at 1. So the horizontal asymptote appears to be y equals 1. Now, that doesn't mean you have that factor in your numerator. What it means is that the degree on the top and the degree on the bottom have to be the same. And when you look at the coefficients of the leading terms, they would have to equal 1. So not negative 1 like that would be out. Has to equal 1 when you do that. So it has to be this guy. Okay. All right. All right. And then one more of those graphing kind, it looks like. Yeah, this is long. Okay. So we were to that one. Okay, so here's a little more. One more to analyze. Okay. me snip that. Okay. So this one has a vertical asymptote at x equals, the scale's a little weird here. See how it goes by 2? So x equals -4. That means there's a factor of x plus 4 in the denominator. Okay. Then you're going to have a slant asymptote for sure. So the degree on top is 1 more, which is true for both of these guys. You might look at where, let me blow this up a little bit, where it seems to be crossing the x-axis. And remember the scale. So it looks like it's crossing at -2 here on this side, at -2 on the x-axis. And then maybe over here at, can't tell if it's, that's really hard to see. I think it's in between the 2 and the 4, so I'd say over at 3. So you would have an x plus 2 and an x minus 3 on top. So it should be that. And then you could work it out and see that it would be this one. Okay, that one was kind of hard to do though from the scale of what we were given. So I might have actually gone in. Another thing I could have done is maybe plugged in some points just to kind of see what it wound up turning out to be. Like plug in a -10 and see if you get something that's here where it's supposed to be. Okay. All right, so I think I'll stop that and call that graphing part 2. Then we'll do the last